Welcome everybody to what, if I haven't lost count, is session number 3 in this series where Toon and I are talking about, and we hope, fielding your questions about this general business of SmartDB. Yes.
Let's start. So one point that I wanted to make in this third episode is, or one topic that I wanted to touch is the topic of code classification inside the database. And I'm going to talk about that at a high level. Certainly not going to explain how intervals are going to be done in SQL or PSQL, what we were discussing about just a minute ago, at a high level. Now, before I do that, I always spend 2 slides for any potential newcomers on what we mean by SmartDB. This is my really 2-slide short definition of it. SmartDB is how you use or fail to use the database. Do you use the database just as a persistence layer or as a full-fledged processing engine? And SmartDB is, of course, about the latter, using the database as a processing engine. We talk about transactional business applications within the SmartDB arena. And these business applications that do transactions conceptually have, at a very high level, 3 layers of software or of code, or however you want to call it. They have at the bottom the table store, the data store that has all the tables. In the middle, this thing called business logic, and I'll be talking about that the next 15-20 minutes. And then at the top we have the various user interfaces, of which I'm depicting the 2 most common, the user interfaces, the graphical user interfaces displayed in web browsers nowadays, and the software interfaces nowadays usually done through RESTful calls, RESTful services, endpoints. Now, the 2 distinct approaches that we see at the left, the database is a persistence layer. You see the business logic blob outside the disk labeled DBMS. And at the right, you see the DBMS disk spanning that blob, also indicating that within the SmartDB paradigm, we envision that business logic should be implemented inside the database. It has many advantages that we talked about the last 2 episodes, and we'll probably touch upon a few more in the future episodes. Yeah, so using the database as a processing engine is called the SmartDB approach. Of course, the user interfaces and the endpoints will always live outside the database. Now, what I would like to talk about is, because this is always a point that is being asked when I talk about the SmartDB paradigm, is how do you prevent what I have here, one big pile of PL/SQL spaghetti code inside the database? And my answer to that question is basically the same as how do you prevent one big pile of Java or JavaScript spaghetti code outside the database? You adopt a sound code classification. In the no PL/SQL approach, in the do everything outside the database approach, we have model view control frameworks that help us do that, or other types of MVVM types of approaches in the new JavaScript world. And I would like to talk about how can you adopt a code classification inside the database, and again at a high level. So I'm going to start with this picture again. And before I can talk about dissecting this business logic thing into smaller areas, I want to make a few points about the table design, the database design itself, because from that already originates a code class. I talk about the table data store here in the sense that it should hold a proper, it should hold a proper relational database design. And by proper, I mean twofold. I mean 2 things. Of course, it must fit the business requirements, but it must also be sound. And in sound, I mean it must follow relational database principles. Yeah, the first is up to you, up to the information analysis to make sure that there's a good fit there. The second is about education. You cannot design a proper relational database design unless you know some of the underlying theory that this relational database design is all based upon. So let's talk about that. In the second meaning, when you have a proper database design, and I will discuss a couple of guidelines in a minute here, you ensure that you won't have all kinds of various issues that you normally see in applications that are not based on a proper relational database design. And I've listed a couple of issues down here. I'm not going to read them up all out loud. You can read them yourself, and you can look at the recording later on. And creating a proper relational database design prevents these kinds of issues. In the end, it will ensure that your whole application is easier to maintain, but also will have a better performance. Now, let's go to some of the guidelines that that I have learned them during my career and that I employ successfully whenever I design a database. So I'm going to provide you with some of the guidelines from my point of view. The first guideline is, and I hope that most of the people on the call won't think this is a really crazy one, is you should always ensure that you use the third normal form or the Boy-Scott normal form if applicable. Now, you may ask, what is he talking about here, especially if he says Boy-Scott normal form or third normal form. I'm not going to explain what that is. That's out there on the internet. Just Google for it and you can educate yourself. But the reason why I say this using these forms, normal forms, is because then you avoid structural redundancies. And structural redundancies are really bad because redundancies need to be maintained and give rise to additional code in your application code base. So if you use third normal form, you won't have structural redundancies in your database design, and you won't have to build additional code to maintain these redundancies also. Now, what I also always say right after the first one is don't design incidental redundancies either. This is what I sometimes call premature optimization inside the database design. For instance, you may think about, should I add a total value column of all the order lines at the order level? Because I have a lot of screens that always want to do a sum over all the prices of the order lines within a given order, and it needs to be displayed at the order level. For me, you should always start out not doing that. Here again, you might end up with a situation where you will spend more CPU cycles maintaining the incidental redundancy during inserts of order lines or changes of order lines than you do in not having this redundancy, but always having to compute the sum of all the order lines. Often, it's totally not necessary, and introducing an incidental redundancy will just have you end up having an application that spends more CPU cycles rather than less, due to the maintenance that you need to do there. The third guideline that I always have is use a surrogate. Whenever you use a surrogate or synthetic key on a table, for instance, it's a very common practice where we use a sequence-based meaningless primary key on a table. This table should always have a second business key. Because if you don't have a second business key, then you might end up in this table with two rows that are exactly the same on all the columns except for the synthetic key. And I invite you to start thinking about whether that's a situation that you really would like to have, whether that's something that you desire to ever happen in this table. Very likely that's not the case. So there was most likely always a concatenation of a couple of other columns that also constitute a key in the sense of the database, relational database theory. Number 4, put different things in different tables. And this is all about avoiding that you have a column inside a table whose contents mean something different over different rows. So depending, for instance, on another column, this column might have, I don't know, the manager's name, or depending on another column value, this column might have the department name, or might have whatever kind of data in it. Columns should have always a single meaning inside a single table. If you have a column that has different meanings, again, depending on a different column in that table, you're not having a proper relational database design. You should probably have introduced 2 tables that has the column each in the different 2 tables with the single meaning that you had in the first design. The other thing is put special things in separate tables. And this is about what's sometimes referred to as subtypes. So when you have a table with a whole bunch of columns that are all mandatory, but you also have, let's say, 3 columns that are optional, but they are optional only for certain rows in that table. Again, depending on the value of another column, these 3 rows must hold a value. And that's typically an indication that you have designed a subtype inside a supertype table also. For me, that's a bad database design. Subtypes should always spin off the supertype table with a 1-to-1 or 1-to-01 relationship, to be more precise, and only have those columns that were optional in the original table but now are mandatory in the new table, and they will only have a row in that new table when they apply for a certain row in the supertype table. Now, the first thing that I should have started with, number 0, is you should always choose your table and column names wisely, because they are the first stepping stones in understanding your database design. Yeah, I've been involved in a couple of projects years ago where tables had and columns had totally meaningless names, and that's a tough spot to be in. Let me put it that way. Now, never allow columns, this is the last one, never allow nulls in columns that are involved in what I call data integrity constraints. And I'm going to clarify that a little bit more, and that will help me end up in a first code class, which I want to talk about. When I say the word data integrity constraints, I mean it in the broader sense of the relational model of data, not just the constraints that we can currently do declaratively in the SQL products, like Oracle is, that we have. We can do check, primary key, unique key, foreign key. But the SQL standard includes this concept called a SQL assertion that offers you the opportunity to specify or to declare any constraint that you might have inside your database design. They are basically check constraints that allow subqueries. Of course, we don't have SQL assertions yet, but I want to convey the concept of a SQL assertion here. So this is an example SQL assertion. Select count star from emp, where job is president, must be smaller than or equal to 1. Yeah, we only allow no or just one president in the employee table. And your typical OLTP database design will have many of these constraints that you can assert as a SQL assertion, that you can declare as a SQL assertion. And you, and the last guideline is all about whenever you are able to assert a constraint in this way in your database design, all the columns referenced by these assertions must always be mandatory. For instance, if I have this assertion, my rule is going to say job cannot be nullable. Job must be not null. The reason why I'm doing that is because you will end up building code to maintain these SQL assertions. And nulls are always a dangerous thing to program. They always give rise to bugs inside procedural code or inside SQL statements, etc. So by ensuring that all the SQL assertions, all the columns referenced by the SQL assertions are always mandatory, you'll end up in a situation where you can easily, with less effort, build maintaining code for these things. Now, a couple of you on this call already know about this, but out there in the Oracle developer community site, I have a database idea. In case you haven't voted yet, we're thinking inside Oracle of providing support for SQL assertions in a future release. If you vote for it, the likelihood of us actually doing this increases.
I've got a little question for you, Toon, if I may. Can you hear me?
Yes.
Yes. About that recommendation never to involve nulls. What has been over the many years, your human experience there? Did you find that, oh my God, for reasons stemming from the business analysis, ended up with a nullable column in such a constraint, and now I'm going to have to strain to get rid of it? or did you find that the mere idea of expressing your constraints coherently and refining them into SQL assertion speak led to that result naturally?
The last one. The last one.
Right. So, yes, that kind of as I suspected. So this is not a piece of recommendation that needs a lot of effort to follow, and you could almost paraphrase it to, at the courses level, really, really think very clearly about all the rules that you're deducing from the business world.
Yes, yes, yeah. So at a high level, it's not rocket science. Again, third normal form, no incidental redundancies, put separate things in separate tables, which is all about subtyping, and don't have columns that have multiple meanings. And then the last one, if you have SQL assertions that involve other columns that are not already involved in primary keys, check clauses, or foreign keys, make sure those are also always not null. Now, the point to make is, and now I'm coming to my first code classification, since your database design will have many of these constraints, you are going to have to write code to enforce them. Yeah? And enforcement is required during transactional APIs. Whenever you change the data, you're going to have to think about what are the insertions involved in this transaction, what validation code should I write to check if the transaction currently at hand is allowed or not. All code that you write in this sense, to me, is what's called data logic code. This is what we call within the SmartDB paradigm data logic code. And that's a separate code class. There are different approaches how to do data logic code. Throughout the years, we've seen people using table triggers or having table APIs and embed validation code inside these table APIs, or have all the validation code out in different rule packages and have calls to these rule packages from the table APIs or from other modules. And there are also various tricks around which involve function-based indexes or materialized view tricks to implement certain subclasses of these SQL assertions. I'm not going to talk about that. That's, for me, that's at the moment not interesting. But the point that I want to make is this blob I can now split up in 3 areas. I have transactional business logic, and whenever I'm going from upwards downwards to the table. Whenever I have transactional business logic, data logic code, the class that I just defined, is also involved. And I have query-only business logic. I have query use cases that just produce data to be displayed on a page or to be given back to a REST call. Those obviously don't involve data logic because they don't change data. So the guidelines that we use whenever we go SmartDB is we are trying to specify whatever we can declaratively at the table levels. The primary keys, the unique keys, foreign keys, check clauses within constraints within rows. And we want to treat this thing called data logic separately. And your challenge here is to end up with some way of dealing with this. And I've had a few ways of how to deal with this at the previous slide, to make sure that you don't repeat yourself. There's a big danger that you start repeating yourself when you write data logic code, because different transactions might require the same SQL assertions to be validated, the same constraints to be validated. Make sure you do the validation code at a single place in your PL SQL code base. And if you do that, then the transactional business logic, what remains as transactional business logic, will be a clean procedural code that does the insert, updates, deletes, maybe with embedded queries in it, and that only has error handling. Error handling in the sense of whenever a data logic module that you reference inside this business logic module gives you the signal back or raises an exception that something is wrong, you just have to handle that error. Over here, query-only business logic, that will just be procedural code, PL SQL with embedded, very likely set-based SQL statements. And then at the top, we have our du jour technology, Oracle Jet, Apex, those kinds of things. And in the middle, we have the REST enablement of the API layer. And the API layer is just the disclosing the modules in the database that are actually the top-level modules to be called from the outside world. Now, of course, you will have inside your transactional business logic or in your query-only business logic, you might have things that you code at more than once. Yeah, and coding more than once is always a bad thing. So you have to apply common sense dry across this whole thing here. So whenever you see you can push something down inside a shared view or push some procedural logic down into a function or a procedure, please do so and make sure that that logic is only visible or programmed at one place. Yeah, and the point, the big point, or my personal experience has been, whenever you ensure that these yellow boxes are separately visible inside your code base, either because you have them in a separate schema or you have some naming convention for these modules or whatever, whenever you make sure that those are separately visible, you will see that the real meat of your application, that these two things that you will have to program will not end up being spaghetti. It will end up being straightforward, highly maintainable procedural code with embedded SQL. Yeah, so again, what I just said, how do we make this visible? Well, we materialize the code classification, a thing that Bryn already talked about a couple of last session or the session before that, where we introduce preferably multiple schemas to all these code classes. We have, of course, we have the connect schema at the top that actually doesn't have any objects because it's used by the connection pool to connect into the database. Then we have the API schema. Those are the empty packaged procedures, jackets on top of the actual meat that are being granted to the connect schema so that they are callable from outside. And then we have the code schema that holds all the business logic and the data logic. I say and the data logic here, but let me make another remark about that in the next slide. And then we have a separate storage schema that holds all the tables and the declarative constraints. And again, why would we want to do that? It's very simple: separation of concerns. As soon as you start separating concerns, you start creating overview. You have different things in different schemas, and it helps you making everything more maintainable. Also, security-wise, we can apply least privileges principle per schema, which can be done in much more detail than I'm talking here, because I'm only talking about it at a very high level here. Visualizing this, the storage schema, the business logic schema, the API objects, and then the connect schema, where the connection pool connects into. Now, and you might say the business logic schema only has the business logic and we put the data logic schema in the table schema. Maybe you choose to create yet another schema in between here that has the data logic schema. To me, actually, if you ask me honestly, those are minor issues. The big point for me is make sure data logic code is separately visible and separately maintainable. You will have constraints that change over time. Wouldn't it be nice that you can go straight to the package that has all the code related to this at most one president, for instance, or to these rows that have a begin and a start date cannot overlap in this table type of constraints. So if you have that, you create a maintainable situation of your code base. And I have one last picture here where I talk about how you might think about also making sure that from a maintenance point of view, whenever you have something in a page out there in your application for the users, that you can very quickly find the code in the database. Typically, a page in your application is part of multiple flows. You can have a page, and depending on how you arrive at that page, different data is to be displayed at this page. The page can have multiple buttons that, going outwards, how do you call it? Need to execute different types of transactions. So all code for a page, for me, could be consolidated in a single package. A single package that has all the render APIs, use cases, stored procedures, package procedures, and all the package procedures for the process APIs. And the package name, somehow, if you create a naming convention that helps you match this package to a certain page out there, or that helps you match this package to a certain REST call or set of REST services that you offer for a different application out there, that helps you to very quickly drill down into your code base whenever something is wrong with page X or whenever something needs to be changed on a certain REST endpoint. So naming conventions inside the database in terms of your stored PL SQL modules is very important also. And of course, we have the API, the codeless package on top of that. Yeah, again, I talked about this. Issue resolution and impact analysis helps a lot whenever you make sure you have thought about things like this. And with that, that's the high-level code classification architecture that I wanted to present in this third office hour.
Can I make just a little point? You often make it more explicitly, but it's nice to have a change of voices here. Go back, yes, on that slide there, you mentioned impact analysis. I think it's fair and indeed proper, almost mandatory for Toon and me to talk in terms of always the latest current technology. I suppose that's 18 if we're going to be careful, but for my present purposes, it's quite sufficient to talk about Oracle Database 12. I'll just point out that this feature called PL Scope lets you discover far more about the objects that you, or the phenomena you reference in the world of the data items, the tables and their columns, than it used to do. And this is gold dust. You can discover by ordinary use of SQL and by packaging this up in your own bespoke reports, what code references what tables for what purpose, and at the next level of granularity, what code references what columns in what tables. And when I say for what purpose, I mean insert or update or delete or select. And with that information so readily available, you can so easily trace backwards, can't you? If for some reason you've discovered you need to increase the width of a column because you'd misanalyzed the business world and now you realize the present column is too narrow, it's one thing to change it, but the other is to discover the various places in your code that need to accommodate it. Now, a lot of the accommodation in the database code can be self-healing, I suppose, in many cases, if you've used the style of anchored declarations. But beyond doubt, these things are going to emerge, of course, into the user interface. And this use of PL Scope, as mentioned, together with the conventions that Toon has been recognizing here, gives you a mechanized way of discovering in a heartbeat which UI screens need to be adjusted in response to this change. And surely that's a far better way of going about things than simply thinking about it or simply waiting until the bugs are reported when screen N, among a large number of them, happened not to get a rewrite in connection with this. And just to hammer a point, that ability to embrace all the relevant metadata that determines this whole back-end data-related part of your application in one simple mechanism where the data is really, really, really available for the mechanism to use, well, that's unique to the smart database paradigm.
Yeah.
So now the questions. I'm just going to read one out and not respond to it now. It comes from our friend Jorge there in Barcelona, and he is drawing attention to the fact, without saying if it's good or bad, that some applications, maybe those who've drunk the Kool-Aid of the in-memory, are combining OLTP use cases with various sorts of what you might call data warehousing use cases in the same database backend, and therefore to some extent at least in the same code base. And he's wondering if we have anything to say on that. Whatever we might say on that, I think that Toon and I would like to think about that and defer answering that to a later time.
Well, I can make a short comment here because this too is a question that I've seen earlier. We make a very specific statement about APIs into the database are all JSON in, JSON out package stored procedures. This is based upon the fact that our contexts are OLTP transactional business applications. Now, if you have inside the OLTP business applications, you're using the in-memory option to also cater for analytics or BI type of querying from third-party tools, then for sure you must have an opening into the database that allows straight SQL queries, because that's what these tools do. These tools, these third-party, but we have them ourselves also. They generate SQL statements from within from some metadata specification layers that are configured in these tools, and you would have to allow SQL statements to be submitted straight into the database from these tools. Sure, but make sure you do that via a separate schema, that then only has access to those tables that you want to have access via these third-party tools.
And strictly only read access too.
Yes. So don't reuse the connect schema used by the connection pool in the Java tier for that. Have a separate schema. Configure a separate schema for these tools. Any other questions, Bryn?
I'm reading it now. There's comments, but I haven't yet seen another question. Your friend and mine, Pete DeVissa, is talking about using views in pursuit of exposing a relation for outside of the database generated query to use. I guess in one sense, you already had that on a slide earlier on. I believe you said if you find it useful to encapsulate some frequently occurring query pattern, well, by all means, have at it. And this is, I think, Pete, only another example of that same thinking. So really the deeper question here is very much one of taxonomy, one of definition, one of how we use our terms. And the question is often put, I always associate this with Philipp Salvisburg in Switzerland. Does the SmartDB paradigm allow the use of views as part of the definition of the API, so that outside of the database entities can get their queries at least done that way? And my answer would be, as a simple, almost naive matter of definition, no. Any terms you use are most useful when they have a crisp, terse definition. And I would like to say that the SmartDB paradigm is definable. It's definable at two levels. One is very, very, very operationally, and that's just that the one or several connect schemas that are exposed to give access to the database within this paradigm are constructed by the well-known mechanisms of what they contain, namely nothing, and what privileges are granted to them, namely only execute on other things, that they are constructed to allow only access through a PL SQL API. Now that implies a subtly different question, which lies behind what Pete just typed, and that's if a database is exposed to some clients using the SmartDB paradigm, does that mean that no other exposure at all is allowed? And it would seem to me that the answer is no, it doesn't mean that. And this BI case is an example where the single corpus of data in the tables that's ultimately the persisted reality of the database might have another use. And provided, especially now, provided that that use is query only, then have at it. By doing what Toon said and exposing things as views for outside of the database SQL, you do run various risks, namely that it's no longer one authority who's responsible for writing the SQL and who stands for both its correctness in the sense of giving the results that your plain English statement of what results you want to see express, and in the sense of its performance characteristics. But if you're willing to separate your concerns and share that responsibility, have at it. But I think the rule that we have to stick to, Toon, but you can comment if you disagree with this way of putting it, is that you can't let go of the authority that makes changes to the data. That must be under the control of a strict SmartDB paradigm as defined.
Yes, yes.
So that would accommodate the huge class of Apex devotees out there who want to talk about SmartDB and who like a lot of the ideas that you heard from Toon just now. We would have to say to them that your Apex client, as if we think of it in that formally separated way, has two subsystems, a query-only subsystem and a data-changing subsystem. And our recommendation would be that you use the smart database paradigm, absolutely, strictly, non-negotiably, no violations of it in slightest iota, for the data-changing subsystem, and then take your own decisions about how you satisfy the query-only requirements. And if you think views are useful here, have at it, but don't complicate our whole discussion space by calling that a variant on the SmartDB paradigm. Rather, it is what it is. Can you live with that, Pete, out there? Let me see a typed answer from you. Yes, Pete can live with it. Victory. And we have a question. All the questions are coming from that hotbed of intellectual activity, the Netherlands. Now we've got one from Rob Vanderberg, and he says, I'm going to read it without having pre-screened it. Are you recommending to implement the table triggers? I'm going to answer this, on separate schemas. And I'm simply going to say there's a tension here. You might think that putting triggers to be very specific now. You've got trigger on T, who is supposed to be created on table T. And certain concerns, code classification concerns, might prompt you to think that you should put on T in one schema and T, the table, in a different schema. Well, you'll find that if you want to do that, you can't unless you start giving the owner of on T any privileges. And I would say that, as in many cases in life, there's a tension here. You can't both have that cake and eat it. And I would say that if you want a stronger principle even than the natural, than wanting to win the natural benefits that using schemas for code classification bring you, an even stronger principle is don't let a single any privilege into your regime. And the reason is sad but true. It's that studies have shown, and I'm not going to go into the detail, that well nigh any privilege, no matter what it is, lets the devious exploiter do terribly tortuous and mischievous series of escalations and get to be DBA and more. And the other sad fact is that you simply cannot trust a large number of people to know about that thing. A simple regime is where you can get the people who know how to log on to the database with any user who's got a single any privilege or more. If you can get them all in one room and see them and interrogate them, you've got a hope. Otherwise, if you've just federated it out and out and out and out, you're just out of luck. And for that reason, I would say that you have to sacrifice the code classification imperative there to avoid using any's.
Yeah, Rob also touches on another very sensitive topic. He has transactional business logic between parentheses when he talks about triggers. We discussed, I think we mentioned this in an earlier session. Let's go back a little bit. So I talked about I mentioned using triggers to implement data logic. Yes, you can do that, but it's very difficult. Make sure you think about it really good and make sure that you have a couple of people in your development team who can do this for you, implementing data logic, multi-row, multi-table crossing constraints using row level and statement level table triggers. The essence of these triggers is that they will only query data. They will query data to see what has changed and is this allowed or not. And they will then optionally give a raise application error to make sure that transactions that violate a constraint don't proceed. Now, you can also have triggers that have in them transactional business logic, that have in them embedded insert, update, delete statements. This is considered to be bad practice. It's a sensitive topic. I think the majority of the PL SQL and SQL community out there is in agreement with me, is that you should not do this, because whenever you do that, you are cascading logic. Whenever you insert into a table, something else fires, namely the transactional business logic that you have in your table triggers. They then execute DML against other tables that again may have transactional business logic triggers that cascade even further. And before you know it, you'll end up with a cascade of code going off on a single insert statement that you cannot, that is very hard to debug or to maintain, etc. So for me, I would never do that. And I agree with you, Bryn, that if you use table triggers to do data logic, yes, you will have to put them in the table schema, because otherwise you'd have to grant the create any trigger privilege to another schema. And we do not, from a security point of view, we are very hesitant in allowing that. Yeah.
And there's another question waiting from yet another acquaintance, Gijs, here. But before we get to that, I'm just going to remind everyone, in case you've forgotten for even a microsecond, that I have two jobs here at Oracle. Not only am I PL SQL product manager, but I'm product manager for edition-based redefinition. And you can't hear the word edition-based redefinition and know anything about it before you immediately recite those three things: edition, wait for it, editioning view, and it's coming now. What's the next one? The next one of the triumvirate? It is none other than the cross-edition trigger. And I'm not going to teach EBR now, but I will just say that cross-edition triggers have the special property in the world of EBR that they're not an integral part of the application. When you come to do an EBR exercise, you work out what use cases you're about to do need synchronization. And for those, you design and implement the cross-edition triggers. They sit there for as long as you're doing the patching. And once you're over, you whip them away at the earliest opportunity. And the subtext there is that you need a certain intellectual stamina and certain background to be able to do EBR successfully. And there is no better alternative than the use of the triggers. And I don't want anyone to think that as EBR product manager, I would disapprove of the use of cross-edition triggers. On the contrary, it's the only way of the use case being met. But that's a very, very, very special case. Yes. So now we've got another sort of verging on the academic question. Shall I read it out, Toon? You can see it there too. Sure. It is from Gijs, and it's, shouldn't views be an integral part of the relational model, so that some entities, as you would have them in the pre-physical world, where you're just drawing boxes and arrows and understanding the business world, so that some entities are deployed as tables and others as views, which, of course, sit on top of other tables or indeed other views? That's the question.
Yeah, and the answer is, of course, yes. I mean, but to me, this is going back to the slide where I said, apply common sense dry. If you have multiple use cases, and I'm gonna use an example in the employee department database. If you have multiple use cases where you always query employee data in conjunction with the department name, for instance, or put otherwise, you are always joining to Depno in order to get that department name at the record level where you have all the employee data also, then yes, create a view that has that entity, that extended employee entity, that retrieves the department name already as a shared view at the bottom on top of the table design to be used by query business logic, data logic, or true business logic modules. But of course it can be complexer also. Yeah? If you have an entity that involves joining two tables, or maybe have a group by and some aggregation going on, by all means create a view for that and make sure that you have that definition, that entity definition, which you apparently want to have, want to be able to use from different spots, defined in a single way, namely inside the view text.
Yes, and that whole discussion lets me just refer to a Twitter exchange that suddenly sparked up into about 87 turns or more in the course of a couple of short hours, maybe 10 days ago, where many, let's say, almost I would call them anti-SmartDB merchants, people who believe that certain things have to be done programmatically, and the only languages that allow those programmatic things that need to be done exist outside of the database. All sorts of strange things were said. For example, it was asserted that using the SmartDB paradigm, to the extent that they knew what they were saying, prevents any kind of reuse of SQL fragments or things like that. Well, you can't express what Toon just said in a tweet unless you find a phonetic way of going. But I hope that at least everyone on this call, having heard what Toon explained there, is ready in person, if not in typing, to counter such peculiar claims about the advantages of having code outside of the database and spraying atomic sequels into the database bring. And one thing I think is guaranteed: you'll meet people who try to bend your ear to that story. Toon and I do all the time, I think.
Yeah, there probably are situations or cases where you can create a better modular solution outside the database. But these are the rare cases, and by far in the majority of the cases you are able to prevent duplication of code inside your PL/SQL code base, either through views, either through separate shared functions or shared procedures, or maybe pipelined table functions. Or there are so many features inside the database that help you deal with various issues where you may want to prevent duplicating code in the database.
Yes. Yeah, sorry. Did you?
And the point that I wanted to make, but I said that at the beginning, is there might still be cases where you cannot be 100% pure in this sense, in the dry sense, don't repeat yourself sense. Yeah. Okay. So to me, that's not an issue to just discard SmartDB all the way, because there are some use cases that might not be done in a pure sense from the dry world.
Yes, and it boils down to what the discussion boils down to is similar to almost any discussion you have in any exercise of software design. There are pros and cons associated with any design, and you often come up with competing designs, and it's never the case that one of them is absolutely con-free and clearly, therefore, the blindingly obvious alternative. It's always a balance that one is overwhelmingly better because it has far, far, far more pros than cons. Well, we just saw an example with the tension between the urge to distribute code in different schemas to materialize a classification notion in a very, very tangible way, on the one hand, and the disadvantage of needing any triggers on the other. And if you were convinced, really, 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 really convinced that some programming techniques that were uniquely available outside of the database were a strong pro, you'd still have to list up all the cons that you took with you if you went for that. And if you remember Toon's talk where he did the, let's say, code word flame graph talk, then you're giving up a hell of a lot in performance. This is where Toon and I disagree slightly in the moral space. I get uncomfortable when people lead with performance arguments. I much prefer leading with correctness arguments. But but I'm happy that one leads with one and another leads with the other, and together we perhaps can get a message across. But the imperative must be for correctness, and correctness has to come from, as I've said many times, the authority to fulfill your responsibility. And that authority has to be in some way materialized, concretized in a whole scheme. And this is what the hard shell does. It gives a wall, a barrier behind which the authority is wielded. And the minute you do any code outside of the database, caveat with the reading use case that we mentioned earlier, but the minute you do any code outside of the database that issues data-changing sequels straight raw into the database, well, your exercise would be now, do it when this call is over. List up all the risks you've exposed yourself to. List up all the various things that have suddenly gone away from you in your armory, and list up all the human beings who have to be involved in the triaging of any security breach that's discovered after the fact. So we are 53 minutes past the hour. I'm waiting to see if any other questions come in. Get typing out there. Let me just have a quick review of the number of attendees.
Okay, so I see Gijs had a follow-up typing. Shouldn't these views then be exposed just as tables to the JavaScript world? I fail to understand the just like tables to the JavaScript world, because we don't expose tables to the JavaScript world. So just like tables, we don't expose these views to the JavaScript world. We have JSON in, JSON out APIs that bring back data from these tables to the UI, to the JavaScript world.
I'd say that's the answer then. You expose them in the same way.
Yes, exactly. If you were, there are many ways we could put this. We may as well use another minute to put it yet another way. It's a sad fact that Oracle database, and as far as I've come across, no other database uses a word which is the super type word for table and view. But you know, when you type a SQL select statement, to pick an example, you don't specify whether it's a table or view in the from clause. You just say from my guy. And these days, with the syntax simplifications that we have in the latest 12, that guy could turn out to be a PL SQL table function as well, all with the same notation if the function had no parameters. Well, for want of a better word, let's just call it a relation. So the question is, should relations be exposed out of the database, outside of the database for various forms of SQL consumption? And we hammered that one to death earlier on. We said in a strict OLTP use case, never, ever, ever. In this case where there's some very ad hoc querying going to be allowed, and the only practical way to allow it is by having hand-typed SQL or generated SQL coming in from outside, well, expose those relations, and who cares if they're tables and views, in the first analysis, expose those relations through a dedicated connect schema. Of course, when you realize that the aim is to allow only select, you soon realize that if the relations you're exposing were tables in that connect schema, well, you wouldn't be preventing insert unless you did some horrible, complicated malarkey that you didn't want to do. The simplest way to do is to have the tables hidden and to expose, even if it's just a select star with no restriction, to expose the table through a view layer whose purpose is not SQL reuse in any sense. Its purpose is entirely as a stepping stone to allow the right privileges to be granted.